Okay, this looks like a rational function. It's a quotient, so we will be using the quotient rule. However, there's more involved here because the denominator is a composite function, so we'll have to use both the quotient rule and the chain rule. You cannot ignore that chain rule. When there's a composite function anywhere, you have to apply it, even if it is in conjunction with the application of another rule. So here's y equals -5 over parenthesis 2t minus 3 squared, and we're asked to find y prime. Well, y prime is -5 over 2t minus 3 squared, all in parentheses primed. So we have to use the quotient rule. Let's use the quotient rule. It is u over v prime. U over v prime equals the bottom times the derivative of the top, v times u prime, minus the top u times the derivative of the bottom over the bottom squared. Okay, quotient rule equals the top, the bottom, 2t minus 3 parentheses squared, that's the bottom, times the derivative of the top, so that'll be the derivative of a constant, you know that's going to be 0, minus the top, -5 times the derivative of the bottom, 2t minus 3 squared. That one's going to be a tough one. And then the bottom squared. That's the quotient rule. Now let's evaluate these derivatives. It's the bottom, 2t minus 3 squared, times the derivative of -5 is just 0, so that first term just disappears, minus the top, -5, times the derivative of the bottom, using the chain rule. Okay, slow down now. Slow down. Let's pause this. Okay, what we have here is the derivative of parenthesis 2t minus 3 squared. So we have to use the power rule, bringing the 2 down as a factor in the front, times 2t minus 3 raised to the original 2 minus 1 power. Let me get that written in there. The 2 minus 1 power, which is the first power, and then hit it, in other words, multiply it with the derivative of the inner function 2t minus 3. That is the chain rule. You have to hit it, you have to multiply it by the derivative of the inner function. So we're going to do that in the next step. We still have to finish the bottom of this quotient rule. That is the 2t minus 3 to the 2 times 2, so there's a fourth power. Okay, so we use the chain rule right there where we hit it, where we multiplied by the derivative of the inner function. Okay, let's do this. This is 0. Double negative is plus 5. Bracket 4t minus 6. Hold on. Put on the brakes. Where did that come from? 4t minus 6 just came from the 2 times parenthesis 2t minus 3 to the 2 minus 1, which is the first power. I just distributed the 2 on the outside inside the parenthesis, and that gave me 4t minus 6. Now I'm going to do the more interesting thing. I am going to evaluate the derivative of the inner function that we had there by the chain rule, the derivative of 2t minus 3. That is 2. Okay, and that's over the denominator, 2t minus 3 to the fourth. And now we'll drop that 0. We'll distribute the inner 2. Okay, we distribute the inner 2, and we get 5 bracket 8t minus 12 over the denominator 2t minus 3 to the fourth, which is 5 times 4 times 2t minus 3. See, I factored out a factor of 4, and then I'm going to cancel common factors. So I have 5 times 4 times 2t minus 3 over 2t minus 3. Oh, a typo! 2t minus 3, not 4. Ignore that. Cancel a factor of 2t minus 3 on the top and the bottom, and we get 20 over 2t minus 3, not 4, raised to the third power. Shoot. Should I fix that, or do you just believe me? I somehow got a 4 in the denominator, which was wrong. It should have been a 3, and I don't want to redo the whole video, so just write it as 2t minus 3, not 2t minus 4. Thanks.